Okay, today in Algebra 2 we're going over function operations. Here is the definition of all the operations here. We are assuming that they're functions. If we're talking about the sum, it can be denoted as this, with the f and g in parentheses, x followed after. And it just means the first function plus the second function. Difference, very similarly, f minus g in parentheses with the x afterwards just means the first function minus the second function. Product means you multiply. The weird one is kind of quotient. It means f over g means you are going to do the f of x over g of x, but you also have to tag on a restriction. G of x cannot be 0, because remember, you can't have 0 in the bottom part of a fraction. So for examples 1, 2, and 3, we're going to use these two functions here, f and g. So for example 1, we have f minus h. So I'm going to set it up. I'm going to take the f of x equation, which is x plus 3. And I'm going to put minus sign. The the h of x equation, because h, is x squared minus 3x plus 2. This is something very similar to what you did in Algebra 1. Now we just have to simplify it. I'm going to distribute the minus sign through the second set of parentheses, giving me x plus 3 minus x squared plus 3x minus 2. To finish off, I'm just going to combine like terms. No other x squareds. So negative x squared comes down. Plus 4x. And then minus 2. Nope, sorry, missed the 3. Plus 3 and minus 2 make plus 1. So there is the answer for f minus h. For example 2, we're trying to find g plus h. So again, just setting it up, g of x is 3x squared minus 4. H of x is, plus sign, h of x is x squared minus 3x plus 2. Because there's a plus sign in the middle, I can just ignore the parentheses and combine like terms. So 3x squared and x squared makes 4x squared. I got a minus 3x. And lastly, I got the minus 4 and the plus 2 make minus 2. So this is g minus h. And the last one using these functions, example 3, we are asked to find f minus g of 2. Now this 2 here does not mean to distribute 2 through. Instead, what it means in this notation is after you find f minus g, you plug in 2, just like f of 2 means. Or you can also say that this means f of 2 minus g of 2. So you can find each one individually and subtract, or you can just use the equation. I personally like to use the equations, so that's how I'm going to go through it. So going through, for the equations, f of x is 3x squared minus 4 minus g, which is x through. Oh crap! I'm sorry, I looked at the wrong equations there. F is x plus 3, and then minus g, which is 3x squared minus 4. So now, because we're just trying to find f minus g of 2, we can plug the 2 in now if we wanted to simplify. I personally prefer simplifying before I plug the number in, just a preference of mine. So I'm going to distribute the negative sign through, just like we did on the example 1, giving me negative 3x squared plus 4. I'll combine like terms. So that's going to give me negative 3x squared. Positive x is coming down. And plus 7 from these two. So this is the expression, but that's not the answer this time because of this extra 2. Again, I'm going to say that that 2 does not mean distribute a 2 through. Instead of what it means is I want to plug in 2. So 3 times 2 squared plus 2 plus 7. Once you get it set up, you can either type it into the calculator or go through order of operations. I'm just going to go through order of operations real quick here. Negative 12 plus 2 plus 7. Negative 3. Answer, negative 3. Okay, now on to example 4. For the next group of examples, we are going to be using the functions f of x equals x plus 3, g of x equals 3x minus 4, and h of x equals x squared. Going through the examples, we have f of x, f times h, so we're literally going to set it up as f of x, which is x plus 3, times h, which is x squared. Once I get it set up, I don't really need the multiplication dot. You can put it if you want. But once you get it set up, all you have to do is distribute. I'm going to do x squared times x is x to the third. X squared times 3 is 3x squared. In this particular problem, that's all I can do. Sometimes you have to do the full foiling. If it's like a 2-term times a 2-term, so like x plus 2 times x minus 2, you would have to do the full thing. But this was a pretty simple, short one. Number 5. We're doing f divided by g. For f divided by g, we take the f of x equation, which is x plus 3, and we divide it by g of x, which is 3x minus 4. Now, we haven't really talked about how to simplify these, so I'm not going to ask you to try to simplify this expression right now, but I do want you to state that restriction. So x can't be equal to, well, what? Let's figure that out. Just take the bottom and set that bottom equation, weirdly enough, not equal to 0, because the bottom cannot be 0. I'm just going to solve this here. It's a simple 2-step equation. Then divide by 3. And I see that x cannot equal 4/3. So your answer includes 2 parts. It includes both pieces. The expression right there and the restriction. The last one here is g times h of negative 2. So again, that means we're going to take the g of x equation times the h of x equation and plug in negative 2. The g of x equation was 3x minus 4, and the h of x equation was x squared. Again, I prefer to simplify this before plugging my number in, so I'm just going to distribute it through and give me 3x to the third minus 4x squared. But again, I'm not done because I actually have to plug this number in. So I will now plug my 2 in. 2 times, no, I'm sorry, it's a negative 2 even. Misread it. Okay, so we've got 3 times negative 2 to the third minus 4 times negative 2 squared. If I simplify this, negative 2 to the third is negative 8. So 3 times negative 8 minus 4 times negative 2 squared is 4. 3 times negative 8 is negative 24. Minus 4 times 4 is 16. So negative 40 overall. And that is all for today's notes.